Alright guys, so what we're going to do in this lesson is we're going to talk about modeling quadratic relations. Okay, so this is the beginning of our new unit, and the unit's actually called quadratic relations. Okay, so it's going to be broken up into two pieces. In this unit, what we'll talk about is we will discuss equations that are already in what we call vertex form, and in our next unit, we're going to take them in what we call standard form and transfer them into vertex form. And basically, we're going to try to solve problems that would arise if, say, you took an object and you threw it up in the air and you caught it again. You have obviously thrown a ball before, and it flies through the air, and it takes kind of what we call an arc. Now, in mathematics, we call this arc a parabola. Okay, so the next two units, we're going to focus on this kind of arc motion, or a U or N-shaped curve. All right, so you'll see on your handout, we're going to start with inactivity. So the activity consists of us taking some points in a data table and putting them onto a curve. Okay, so first of all, we need to identify that all of these values will run along our x-axis. So the x-axis, remember, is the one that runs left to right or horizontally. And then the set of y values will be up and down, so a vertical axis. Okay, so let's go ahead and try to put down the first point first. So that's at 4 and minus 3. So 4 on the x-axis, that's right here. So I went 1, 2, 3, 4. And I want to go minus 3, so I'm going to go down 3. And I believe that is this point right here. Okay, so the next point that we have is 5 on the x-axis and 0 on the y-axis. So that will be 5 on the x-axis and 0 on the y-axis, means I don't move up or down at all. So that's this point right here. The next one would be 6, 3, so I go over 6 on the x-axis and up 3, 1, 2, 3. And we're going to put that point down as well. And we continue this and we get 7, 6, so that means 7 on the x-axis, 6 on the y-axis, so that gets me to this point right here. And then the next one is 8, 9, so I'm going to go 8 on the x-axis and 9 on the y-axis. And sure enough, our last point here is this one right here. Now, if I was staring at these points, there's something I may notice about them, and the fact that they are lined up forms a straight line. So I'm going to try my best to draw a straight line. Oops, that's not very straight. Here we go. Let's go ahead and try to draw a straight line through all of those points. And again, I'm off. Holy moly. Here we go. Now, that's the best I can do. Sorry, it should be a straight line. And we call this a linear. So L-I-N-E-A-R. And we call it a linear relation. Okay? Or a linear graph or linear function or something. Okay, so let's try looking at the next set. So -1, -3. So I'm going to go actually left on my x-axis to -1. And I'm going to go down to -3, which is this point right here. And let's go ahead and put a dot there. The next one's at 0, -4. So 0, -4 is right here. Okay, the next point is 1, -3. So 1 on my x-axis. So I go over 1, down 3. That gets me this point right here. And then 2, 0. Okay, so that's 2 on the x-axis, 0 on the y-axis. 3, 5. So I'm going to go over 3. So 1, 2, 3. And up to 5. So that's right here. And I notice right away that this doesn't quite look like a straight line. It looks more or less like it is a curved graph. So I'm going to try drawing a curved graph in here. So there's that, what it looks like on one side. On the other side, it's kind of taken on this other shape. So it kind of takes on this shape. Now, when I look at that, I notice that this is not necessarily a straight line. This is actually what we call a quadratic. So QU, quadratic relation. Now, a quadratic relation is quite different from our linear relation. So first of all, you can notice that the linear relation is a straight line. The quadratic relation is a U shape, or it may actually come out to be an N shape as well, but it's this curved shape. where there's always a lowest point, which we're going to discuss, and that's called the vertex. You're going to have that it either opens up or down. We'll label that as either concave up or concave down, but all of that will come later on in our unit. Okay, so for now, let's discuss this idea of a linear equation and a quadratic equation. Okay, so using our shapes here, let's try to fill in these blocks. So the graph of a linear equation, and then our linear equation is going to be y is equal to mx plus b, and we'll call m here. This will be what we called our slope. So that's the steepness of the line. So we're talking about this straight line right now. And then b, you may remember from previous math classes, called the y-intercept. So the y-intercept is where it crosses the y-axis. So it's not easy to see on this graph here, but on the quadratic, we also still have a y-intercept, and that's where it crosses the y-axis. So you can see this y-axis, the up and down one, it crosses at 0 on the x-axis, because it's not left or right at all. It's actually sitting right on the y-axis at -4. And you can see that in our table as well. So at 0 minus 4, we have, this is called our y-intercept. Okay, so let's go ahead and discuss a little bit more about this quadratic relation. Actually, sorry, I'm not done with the linear one. So the graph of a linear equation, y equals mx plus b, is a, we can say here, straight line. Okay, so we have a straight line here. And then our quadratic relation, we'll start with this equation, y is equal to a, and then we'll put in here x minus h, we'll call it squared, plus k. And we'll discuss what each of these variables mean later on in the unit. But for now, we can see that there's a difference in how the equations are written. This one has a little exponent 2, whereas this one doesn't really have an exponent at all. Okay, it has the exponent of 1, which we just typically don't write. Okay, and we call this a quadratic, or it is a parabola shape. So parabola. Okay, so it's a parabola. Now, it's easy to see if we have the graphs, which one is a parabola and which one's a straight line. But sometimes we might be given some data here, and we don't really want to graph it. We wanted to find out, first of all, if it's a straight line or if it's a quadratic or a parabola shape. So let's discuss what we mean by the first differences. So the difference in mathematics, you may remember, the word difference means subtraction. Okay, so anytime you see what's the difference between these two numbers, you can say, okay, it's the subtraction of the two, and we can work that out, right? So what we want to do is we want to say for evenly spaced x values, so what we want to do is, if we're given a table, is make sure that all of our x values are evenly spaced. So let's take a look at this first one here. So it's -3 to -1, and then -1 to 1, 1 to 3, 3 to 5, 5 to 7. They all have a difference of 2. So for example, 3 to 5 makes it, you have to add 2 to 3 to get to 5, and then you have to add 2 more to 5 to get to 7. Or if you go 7 minus 5, you get 2. 5 minus 3, you get 2. 3 minus 1, you get 2. You get the idea. All of these will give us a difference of 2. Okay, so first thing we always want to do is make sure that our x values are evenly spaced. So after we've done that, find the difference between consecutive and we're going to say here y values. Okay, so we want to do the same idea here. So 4, you want to take the second one, so the bottom one here, 4, minus the one that came before it, so 7. So you go 4 minus 7, and if you go 4 minus 7, you get 3. Now the next set we want to do is 1 minus 4. So I'm going to start with 1 minus 4, and I get 3. So we're always adding the higher x value, or the second y value, subtract the one that comes above it in the table. So minus 2, so I have minus 2, subtract 1, and that gives me, here we have minus 2, subtract 1, I get minus 3. I get minus 5. Oh, for goodness sake, 1 minus 4 is negative 3. And then 4 minus 7 is negative 3. I'm sorry, I've made a mistake there. So all of these are coming out to minus 3 so far. So minus 5 minus 2. So minus 5 subtract negative 2. So here I have minus 5 subtract negative 2. So these two negative signs you can think of as making a positive sign. So I have minus 5 plus 2, and I get minus 3. In the next set I have minus 8 subtract minus 5, or negative 5. And I get negative 8 subtract negative 5. And so you can think these two negative signs will make a positive sign. So I get negative 8 plus 5, and that gives me minus 3. So I notice here that all of my first differences are the same. Now if you were to graph this, you're going to find out that you get a straight line. So the first difference if the same, represents a straight line. Let me just put the word line underneath. Okay, so what I mean there is all this data here, this x and these y's, the combination of the ordered pair, so negative 3, 7, negative 1, 4, and 1, 1, will make a straight line if you put them on a graph. Now let's try the same with our second difference. So to determine the difference between consecutive, we're going to say first difference, I'll write diff for difference, y values. Okay, so I have to first find the first difference. So before we do that, let's make sure our x values are all the same. So the difference between negative 3 and negative 2 is a difference of 1. From negative 2 to 1 is a difference of 1. From negative 1 to 0 is 1. 0 to 1 is 1. 1 to 2 is 1. So they're all the same, so we're good to go. So let's go ahead and let's take negative 1 minus 0, and negative 1 minus 0 gives me negative 1. I get 0 minus negative 1. So 0 minus, let's fix that. I get 0 minus negative 1. And I get that comes out to 1. I get 3, remember the lower one, minus 0. And I get 3 minus 0 is 3. 8. So that doesn't really look like an 8. There we go. 8 minus 3. And I get 5 here. And then the last one is 15 minus 8. And I get 7. Now, first thing I notice here is these are not the same. So that means that this data that's in my table does not represent a straight line. So I'm hoping that the second difference is all the same, because that will represent that it's a quadratic equation. So let's go ahead and do that. So I go 1, the lower number in my table, subtract the one above it, so minus negative 1. So again, 1 subtract negative 1. You can think of these two negative signs making a positive sign. So you get 1 plus 1. So you get difference of 2. And I'll go with my next number, 3 minus 1. 3 minus 1 is 2. I go 5 minus 3, and I get 2. And then 7 minus 5, minus 5 is equal to 2. Ah, look at that. Now I have 2, 2, 2, and 2. Perfect. So I can say that the second difference represents we're going to say quadratic equation. And what we mean by that is it's a parabola. Okay, so the second difference, if these are all the same, we get a parabola. Now you can keep going. In further maths, you might see that you want to go to the third or fourth or fifth difference, and finally you'll get a constant. And that just simply means that the exponent on in our equation is that power. So I'll notice here that the first difference, so this had a power of 1, represented a straight line. The second, or the 2 on the exponent, will represent that it is, in fact, a quadratic. So I had to get the second difference before they're all the same. All right, so let's move on to our next page here. So I'm just going to erase my writing, and we'll move on to our second page here. And I'll scroll up to the top. So we just have a few definitions to go over. So parabola, I'm just going to pull up my notes here. A parabola means that we have a symmetric, oops, I need my pen. We have a symmetric U or N shape. And it opens up or down. Okay, so up would be our U shape, opening down would be the N shape. Okay, now a vertex is the lowest or highest point on a graph. So it's that opens up or down. So it's the lowest or highest point on a parabola that opens up or down. Okay, so on this one here, this point at the lowest part of our U shape would be our vertex, or the highest point on this shape here, which is kind of looks like an N, is our vertex. Okay, so the minimum is the lowest point on our parabola. So it's the lowest point on the parabola. Whereas the maximum, just like in its name, will be the highest point on the parabola. Okay, so you can see that the vertex is linked with this minimum and maximum. The vertex is kind of the term that encompasses both the minimum and the maximum. All right, so we may ask ourselves, all right, how can I tell if something is linear or quadratic? So if the graph is a parabola, it's a quadratic. Right? So that means if my graph has kind of that U shape or an N shape, or it's opening up or opening down, it's quadratic. If the first difference is constant, it's linear. We discussed that on our previous page. If the second difference is constant, it is quadratic. Okay, and if the degree of the polynomial is 1, that means that it only has an x term. So that was our like y is equal to mx plus b. And there's a 1 here. So if the power on the x is 1, that means it's linear. If it's a 2, that means that we had, remember our equation was y is equal to a, and then it was x plus, x minus h plus k, and there's a 2 up here. That 2, if we expanded out our bracket, we're going to have x with a power of, an exponent of 2. That means that it's quadratic. Okay? So any exponent will tell you what we call as the power or the degree of our polynomial. Okay? So let's move on to a little bit more of a work, and let's look at these equations here. So I have some equations and some graphs, and we want to try to figure out if our graph or equation is linear or quadratic, and we want to try to figure out what the value at x equal to 2 is. So let's start out with A. So in A, if x is equal to 2, that simply means that everywhere I see in my equation an x value, I'm going to sub in or replace the x with the number 2. So we can do that. We can go y is equal to 3, it's minus 3, or negative 3, and I go 2 plus 1, and I put it to an exponent of 2 plus 1, and I get y is equal to minus 3, and this gives me 3, and it will be squared plus 1. And I get y is equal to minus 3. Now 3 squared is 9, so I'm going to replace that 3 squared with a 9, and I'm going to say plus 1, and I get y is equal to minus 3 times 9 is minus 27. We're going to add 1 to it, and I get that y is equal to minus 26. Now this equation here has that exponent of 2, so that means that it must be quadratic. Okay? All right, so let's look at B part here. So B part, again, I want to replace the x in my equation with the number 2. So that means that everywhere I see an x, I replace it with 2. So I get 2 multiplied by 2, because that was an x here, minus y plus 7 is equal to 0. Now 2 times 2 is 4, minus y plus 7 is equal to 0. So 4 plus 7 gives me 11 minus y. All I did there was I collected my like terms. And I'm going to add y to both sides to remove it from the left-hand side. So I got 11 is equal to y. Okay? So because I had minus y plus y adds to 0, and I have 0 plus y gives me a value of y. Now I have to ask myself, what is this linear or is this quadratic? And I go back to my value on x. So there's no number here, which means that it must have a power, or sorry, not a power, but an exponent of 1, meaning it is linear. Okay, so I have that A was quadratic because the exponent was 2, B was linear because it had the exponent of 1, and let's move on to C here. C is a straight line, so that means it must be linear. And I wanted to try to figure out what the value at 2 is. So if I look at 2, I have this point right here. I'm going to say that y is equal to 3. And I just estimated that from the graph. So I went up from 2, and I tried to match where does it cross on my y-axis. And that was at 3. Now, again, same idea I could do here. And I'm going to try to trace this up. And I get that it is roughly, let's say, I don't know, maybe 5 or 6. So for D, we know that it has this U shape. It's a parabola shape, so it's quadratic. Okay, and that means that my y value is going to be, and I think if I read this off the graph properly, I'm going to guess that it's about 6. Okay, so that leaves us with the end of this activity. So what I want you to do for homework is there's going to be another handout, and I want you to look at the handout and try some of the questions from that handout. Okay,